Okay, students, let us go to the problems of binomial distribution. Here is the problem. Find the recurrence formula for binomial distribution. What is recurrence formula? What is the use of recurrence formula? How to find out recurrence formula? Let us learn. Okay, we know as per the binomial distribution, P of x, probability for x is given by NCX P power of x Q power of n minus x. Okay, here P is probability for getting a success, Q is probability for getting a failure, and x is nothing but number of successes. Okay, now we want a formula for finding P of x plus 1. Okay, that is why it will makes you easy to find out the next value. Okay, without any complication. Okay, P of x plus 1, this is given by, as per this formula, n into c power of x plus 1. X is replaced by x plus 1, n into c, n c x plus 1. Okay, P power of x plus 1 successes, Q power of n minus x plus 1, minus into x, minus x minus 1, that is n minus x minus 1. Okay, now n into c power n c x plus 1 can be written as n into n minus 1 into n minus 2 into up to, we must have how many terms? X plus 1 terms. First term, second term, third term. What is x plus 1th term? X plus 1th term is n minus x. X plus 1th term is x. 1, 2, 3. 1, 2 and so on up to x. These are all x terms. This is x plus 1 term. Therefore, we have x plus 1 terms by x plus 1 factorial. X plus 1 factorial into, we can write down p power of x plus 1 as p into p power of x, and also q power of n minus x minus 1 is q power of n minus x into by q, because q inverse, it can be written as 1 by q. Okay, now I need to separate x plus 1 can be written as x in 1 into 2 into and so on up to x, n into n minus 1 into n minus 2 into here. What is this dot? That is the term before n minus x. It is given by n minus x minus 1. Okay, minus into x minus x plus 1, n minus x plus 1. Okay, this is the term before n minus x into n minus x by x plus 1 factorial means 1 into 2 into 3 into and so on up to x into x plus 1. Okay, x is the before term, just before term of x plus 1. Okay, into p by q into p power of x q power of n minus x. Okay, now here I will separate a fraction. The fraction is n minus x by x plus 1. That is n into n minus 1 into n minus 2. This time last term in this expression is n minus x plus 1 by the denominator last term is x, that is 1 into 2 into 3 into x, as I am separating n minus x by x plus 1, n minus x by x plus 1. Okay, into p by q, p power of x q power of n minus x. Okay, now this is nothing but n into n minus 1 into n minus 2 into and so on n minus x plus 1 by x factorial, okay, into n minus x by x plus 1 into p by q, p power of x, q power of n minus x. Okay, but this term can be written as n cx simply, okay, into n minus x by x plus 1 into p by q into p power of x, q power of n minus x, or simply let us rearrange terms in this product. N cx p power of x, q power of n minus x into n minus x by x plus 1 into p by q. Okay, now this term is nothing but p of x, probability for x successes. Therefore, we have p of x into n minus x into x plus 1 into p by q. Okay, this is recurrence formula for x plus 1. Therefore, by using this formula, we can easily find out the value of p of x plus 1 whenever we know the value of p of x. Okay, that is, complication will be reduced as we compare with normal, finding the values of probabilities for consecutive numbers. Okay, now let us go to the problem. Okay, we will use recurrence formula in this problem. Here 4 coins are tossed 160 times. Okay, the number of times x heads occur, x is equal to 0 or 1 or 2 or 3 or 4, is given below. X is equal to, when among the 4 coins, we are tossing 4 coins at a time 160 times. Okay, in each case we may have a single we may have all coins or tails, that is there are no heads, or we may have one head among 4 coins and 2 heads among 4 coins and 3 heads among 4 coins and 4 heads among 4 coins. Okay, this is number of times, that is among this 160 times we may have 8 times 0 heads, 34 times a single head, 69 times we may have 2 heads, and the number of cases having 3 heads may be 43 among 160. Similarly, maybe all coins tossed are head is 6 number of times among 160 times, that is in 6 times we may get all coins as heads. Okay, these are our actual frequency, that is we need to perform random experiment as practically by taking 4 coins, okay, in the field, and we have to count each time. Okay, and we have to note down how many heads are in your output among 160 times, how many heads are. If there are 0 heads, we have to record here, that is in this way we are getting 8 times 0 heads, 34 times 1 head, 69 times 2 heads, 43 times 3 heads, 6 times 4 heads. Okay, this is actual values, but without doing that random experiment we need to expect these numbers. Is it possible? Yes, we can do it. Let us go forward. Here success means getting head. Okay, therefore probability for getting head is equal to, we know that it is 1 by 2. Okay, now that is P is equal to 1 by 2. Therefore Q is also 1 by 2. 1 minus 1 by 2. Q is probability for getting a failure. And now P of x. P of x is given by the binomial distribution. We have P of x is n c x p power of x q power of n minus x. This is by binomial distribution. Binomial distribution. Okay, now here note that n is equal to 4, small n is equal to 4. Okay, there are 4 coins, therefore have to consider small n is 4. We may have 0 successes, that is 0 head among these 4 coins, there are 1 head among these 4 coins, or 2 heads among these 4 coins, or 3 heads among these 4 coins, and maybe all 4 coins may have 4 heads. Okay, and capital N is given by the total of these values, 8 plus 34 plus 69 plus 43 plus 6, but it was given as 160. Therefore capital N is equal to 160. 160 is considered as capital N. Okay, now we need to find out the probability of each cases, that is probability when 0 successes, probability when probability when x is equal to 1, probability for 2 successes, similarly probability for 4 successes. Okay, now let us find P of 0. Okay, P of x is, as per the binomial distribution, n c x p power of x q power of n minus x. Okay, here n is small 4, therefore P of 0 is, for 0 successes, 4 c 0 p power of, that is 1 by 2 power of 0 q power of, that is 1 by 2 power of 4 minus 0. Therefore here 4 c 0 value is 1, 1 by 2 power of 0 value is 1, therefore we have 1 by 2 power of 4, that is 1 by 16. Okay, therefore P of 0 is 1 by 16. Now we have to find out P of 1. As usual, you can find out it as 4c1 1 by 2 power of 4 1 by 2 power of 4 minus 1, that is cube. But by using recurrence formula we are finding. Let us find out by using recurrence formula. What is recurrence formula? Recurrence formula. Recurrence is given by recurrence formula is given by P of x plus 1 is equal to P of x into n minus x by x plus 1 into P by q. Okay, that is it. But in this case P is 1 by 2, Q is 1 by 2. Okay, therefore 1 by 2 by 1 by 2 is 1. Therefore we can use recurrence formula as p of x plus 1 is equal to p of x n minus by into n minus x into x plus 1. But p is equal to 1 by 2, q is equal to 1 by 2 implies p of x plus 1 is equal to p of x into n minus x by x plus 1. Therefore now we can easily find out the probabilities for 1 successes, 2 successes, 3 successes, 4 successes. That is, for example, let us find out p of 1, probability when 1, that is probability when 0 plus 1. Therefore here x is equal to 0 as per the recurrence formula. Okay, p of 1 is p of 0 plus 1 as per the formula p of 0. Okay, n means 4 minus 0, 0 plus 1, that's all. But here p of 0 value is 1 by 16. 1 by 16 into 4 minus 4, okay, given by 1 by 4. Therefore p of 1 is equal to 1 by 4. Similarly, let us find out p of 2. P of 2 is given by p of 1 plus 1. Therefore x value is 1. Therefore as per the formula, p of 1 into 4 minus 1 by 1 plus 1. P of 1 value is 1 by 4. 4 minus 1, that is 3 by 2. Therefore 3 by 8. Now similarly, p of 3 given by p of 2 plus 1, that is p of 2 into here p of 2 into n minus x, 4 minus 2, 4 minus 2 by x plus 1. X is 2, 2 plus 1. Okay, here p of 2 is 3 by 8. 4 minus 2 is 2, 2 plus 1 is 3. Okay, 3 cancelled, its value is given by 2 by 8. Okay, now finally we have to find out probability for getting 4 successes, that is p of 3 plus 1, that is p of 3 into 4 minus 3 by 3 plus 1. P of 3 is 2 by 8 into 4 minus 3, 1 by 4. Okay, 2 times cancel, 1 by 16. Okay, now we have to find out theoretical frequencies, that is expected values. Okay, expected values are given by this formula, that is p of x is equal to f of x into n into p of x gives expected values. Okay, f of x is equal to n into p of x gives expected values. This is important formula to find out expected values. F of x is equal to capital N into probability of x. Okay, here we know capital N is capital N is equal to 160. Okay, now let us find out f of 0. Okay, f of 0 is given by capital N into 160 into p of 0. Okay, that is 160 into p of 0 is 1 by 16. Therefore 1 by 16 10 times. Okay, therefore when we perform random experiment, there are 8 cases with no heads. Okay, but we are expecting it as 10, almost close to real value. 10 is expected value. We may among 160 trials there may be 10 times having 0 heads. Similarly, let us expect for x is equal to 1 head, a single head among 4 heads. How many numbers are there? Number of trials are there. 160 into p of 1, that is 160 into p of 1. P of 1 is 1 by 4. Okay, 40. Okay, for 2 heads, number of cases having 2 heads among 160. 160 into p of 2. 160 into p of 2. Probability for getting 2 successes is 3 by 8. That is 20 times. 20 into 3. 20 into 3, 60. Okay, now f of 3 for getting 3 heads. 160 into probability for 3 successes, that is 160 into p of 3, probability for 3, 2 by 8. 8 in 160, 20 times cancel. 20 into 2, 40. Okay, finally for getting 4 successes, the number of cases having 4 successes is given by 1 by 160 into probability of 4, that is 160 into p of 4 is given by 1 by 16. 10 times. Okay, if we summing of all of these values, 10 plus 40, 50, 50 plus 60, 110, 110 plus 40, 150, 150 plus 10, 160 times. That is equals to capital N. Therefore, let us compare these expected values with actual values when we are performing random experiment. Okay, here number of cases having 0 elements is 10, but actual cases are 80. Okay, expected value is 40, actual value is 34. Expected value is 60, actual value is 69. Expected value is 40, actual value is 43. Expected value is 10, actual value is 6. Therefore, these values are almostly closer to this value. Okay, therefore without doing random experiment, in this way we can expect these values. Okay, that is how many times we will get 0 heads. 10 times among 60. How many times we may get a single head among 4 tails among in 160 times, 40 times. In this way we can expect. Therefore these are called as expected values. Actually question is find expected values. Find expected values. These are expected values. Okay, The problem may be asked like this: fit a binomial distribution to the data. Maybe in this way we may ask, that is, fit a binomial distribution, fit a binomial distribution for given data, fit a binomial distribution for given data, or find expected values. We may ask in any way. Okay.